Hello, my name is Mila, and I'm going to talk about the evaluation of a binaural cochlear implant sound processing strategy inspired by the medial oligocochlear reflex combined with fine structure processing. The MOC strategy is a binaural cochlear implant sound processing strategy inspired by the control of the basilar membrane compression provided in natural hearing by the medial oligocochlear reflex. This strategy involves the use of contralateral control compression function in each frequency channel, that is, with dynamic and mutual contralateral compression between the two processors. In previous studies, we have shown that compared to a strategy similar to the current clinical standard, which uses independent processors with fixed compression, the MOC strategy improves the speech recognition in noise in bilateral and unilateral listening when the masker was steady-state noise or single-torque masker, when the target and the masker were spatially separated. In addition, in recent studies we have shown that speech in noise recognition is better with more realistic implementation of the MOC strategy, specifically with the Mode 3 strategy, with a slower contralateral compression and greater inhibition in the lower frequency channel, that is, with characteristics similar to the natural medial oligocochlear reflex. For example, this figure illustrates the improvement of the MOC strategies relative to the standard in unilateral and bilateral listening for multiple spatial configurations. And as you can see, in unilateral listening and compared to the standard, the Mode 3 strategy tended to provide better or equal intelligibility in noise. And in bilateral listening, the Mode 3 strategy improved the speech recognition in noise approximately 1.6 dB on average compared to the standard. However, the standard and MOC strategies described in previous studies were based on the continuous interleaved sampling processing, and the standard in medical devices is to have fine structure processing in the lowest frequency channels, and this strategy involves presenting pulses at the time of zero crossing of the bandpass filter output. For this reason, here we test the Mode 3 strategy in combination of the FS4 processing for speech in noise recognition and listening effort. And the hypothesis was that the Mode 3 strategy in combination with the FS4 processing produced better intelligibility in noise and required the same or less effort than listening with the FS4 processing alone. This work was divided in two studies. Study 1 assessed speech in noise recognition. 7 bilateral cochlear implant users participated in this study. Speech in noise recognition was assessed as speech reception threshold for sentences, that is, the signal-to-noise ratio at which participants were able to recognize 50% of the full sentences that were presented, using fixed level speech and varying the noise level adaptively using one down, one up procedure. And here the masker was speech shape noise. SRTs were measured for multiple spatial configurations in bilateral and unilateral listening, and free field listening was simulated by Opus 3 HRTF. Stimuli were processed through the standard FS4 processing strategy based on the MEDAL FS4 strategy and through the Mode 3 FS4. Both strategies involve linked automatic gain control. And here we can see the results in bilateral listening. This figure illustrates the improvement of the MOC strategies relative to the standard for multiple spatial configurations. And as you can see, the intelligibility in noise was equal or better with the Mode 3 strategy. And this also occurred for most individual participants. However, we didn't find significant differences across processing strategies and spatial configurations. And here we can see the same as previously, but in unilateral listening. And here the SRTs were always better with the Mode 3 FS4 strategy. And this also occurred for all individual participants. However, these benefits were not statistically significant. As we have shown, the Mode strategy can facilitate speech in noise recognition. However, it is not yet known to what extent the mock strategy can affect listening effort. For this reason, here we assess listening effort with the mock 3 FS4 strategy. The same cochlear implant users participated in this study. Listening effort was measured using two methodologies: the dual task paradigm, which required that participants perform two concurrent tasks. The primary task was recognize and repeat 10 disyllabic words, and secondary task was recall as many words as possible. And here the assumption is that effort is less when subjects can recall more words. And the other methodology was response times, which were quantified as the time between the end of the stimulus presentation and the participant responses. And the assumption is that effort is less when response times are shorter. Effort was measured for two special configurations in bilateral listening and at three different SNRs that include the individual strategies for each participant. And here we can see the word recall results. This figure illustrates the transform proportion of recall words in assigned units and the corresponding score in percentage as a function of a signal-to-noise ratio for the two processing strategies represented by the white and gray bars and for the two spatial configurations. And cycles illustrate individual mean score for each participant. And here we didn't find differences across strategies and SNR conditions. And the interaction between strategies and SNR conditions were not significant. Here we see the results of response times. This figure shows the response times as a function of the signal-to-noise ratio for the two processing strategies. And as you can see, response times tended to increase with decreasing SNR. However, we didn't find significant differences across sound processing strategies and SNR conditions. And in addition, the interaction between strategies and SNR conditions were not statistically significant. And to conclude, intelligibility in noise was equal or better with the mock 3 FS4 strategy in bilateral and unilateral listening compared to the standard FS4 strategy. However, these improvements were not statistically significant, and word recall scores and response times were not significantly different for the standard and mock 3 FS4 strategies. Therefore, listening with the mock 3 FS4 strategy requires similar effort as listening with the conventional sound processing strategies. Thank you very much, and now my colleague will present his work.